Yesterday, the question that we got, we looked at a polynomial, and they gave us a bunch of examples to try and factor. And so here's another example. They are using the main example too. They said you started with x cubed plus 2x squared minus 13x plus 10, and you found out that x minus 1, x minus 2, and x plus 5 were the factors. So we could write that this statement right here, that x cubed plus 2x squared minus 13x plus 10 is equal to x minus 1 times x minus 2 times x plus 5. Now, something to notice with polynomials and multiplying factors, just like when you FOIL, all of your first terms will always multiply to get whatever your first term is there. And all of your last terms, the minus 1, the minus 2, and the plus 5, they will always multiply to get your last value. And this is going to be the key important thing, because our next set of questions will be, can you just factor this polynomial? Well, if we want to factor it, we've got to find possible factors. And then we can use synthetic division to break it down. But in order to factor this one, it's nice to know that the possible factors could be x plus 1 or x minus 1, x plus 2 or x minus 2. I won't use x plus 3 or x minus 3 because 3 is not a factor of 10. So this is called the factor property, and the factor property states that if you're trying to find a factor of the whole thing, then whatever value you have here, that value is also a factor of your constant term. So when we go to example 3 here, which we'll do right now, and we're looking at factoring this one, we see that our last term, our constant term here, is a plus 2. So if we're thinking of factors of plus 2, the factors of 2 are plus or minus 1 or plus or minus 2. So when we're looking for factors of the whole thing, based on that, the possible factors are x plus 1, x minus 1, x plus 2, or x minus 2. These are the only nice factors that are possible for this. And we're going to find out later there's another factor that isn't quite as nice as these ones. I guess I'm discriminating against it a little bit. But those are the 4 that are possible nice factors. So how do we find out which one works? What are we going to do to factor this fully? So first of all, before we get into this, we're going to write out some steps for factoring. Step number 1, you're going to use your factor theorem, remainder theorem, factor property, whatever you want to call it, to find one factor. So we need to find out, of those 4 that are listed above, which one works. We just need to find one that works. After we find one that works, you're going to use that one that works, use synthetic division, and you're going to write the division statement. And your division statement, remember that's that P equals dq plus r. But there will be no r in this case because there's no remainder. If it's a factor, the remainder is 0. So you're going to write your division statement after using synthetic division with the one factor that worked. Once you've written your division statement, you may be close to done. If your quotient that's left is a quadratic, you can factor that quadratic if possible. Or you may have to repeat steps 1 and 2. If it's not a quadratic, if you started with an x to the 4, after doing synthetic division you end up with an x to the 3 function, you may have to repeat steps 1 and 2 until you break it down completely. So these are our steps. We're going to now look at how do we use those steps. What does this mean for our question? So in our question, one of the things I'm going to start with is I'm going to define, right above here, I'm going to say, let p of x equal this polynomial. That'll just let my notation be a little bit nicer, because I want to check which one of these works. 1 or -1, 2 or -2. So someone pick one of those at random to try first. Usually I like to start with 1 and -1 because the math is easier to plug in. So what would you like to do, 1 or -1? 1. Okay. So we start with plugging in 1. So that means I'm going to plug in 1 for x for all the things. So I'm going to have 3 times 1 cubed minus 4 times 1 squared plus 5 times 1 plus 2. Did I get all my sin? No, it's minus 5. Minus 5 times 1, is it plus 2? It is plus 2. Perfect. So now when I simplify this, this is going to be 3 minus 4 minus 5 plus 2. This equals -4. This means that x minus 1 is not a factor. So step 1, I have to use the factor theorem to find one factor. I have not done that yet. My first attempt failed. So 1 doesn't work. So then I try again. Maybe I'll try, I like doing the 1s first, so let's try -1. It may also not work, but we'll find out. 3 times -1 cubed minus 4 times the -1 squared minus 5 times the -1 plus 2. A negative cubed will still be negative. Negative squared is positive times -4 minus 4 plus 5 plus 2. This one is equal to 0. So we can say that x plus 1 is a factor. So step 1 is just to find one factor. We did that. Step 2 says use your synthetic division with your factor and write the division statement. So in step 2, which I'll do here in blue, if I'm dividing by x plus 1, I put a -1 out here. For synthetic division, you use your coefficients, 3, -4, -5, and 2. Bring down the 3, multiply, add, multiply, add, multiply, add. And you should, if everything worked out right, you should get a remainder of 0 because you knew that x plus 1 is a factor. We can now write our division statement. Another nice thing about letting p of x equal at the beginning is you don't have to rewrite the whole big thing. You can say p of x equals our polynomial. Our divisor was x plus 1, and our quotient is 3x squared minus 7x plus 2. So we've now completed step 2. Step 3 says if you want to factor this completely and you get a quadratic, which we do, 3x squared minus 7x plus 2, now you can just factor it completely using your factor skills from before. We're still going to have an x plus 1. Let's see if we can factor this. If the first term is 3x squared, only possibility, 3x and x. Is there a way to put our last term, to multiply it to 2, so that your outside and inside make 7? So you'd have to check, could it be 1 and 2 or 2 and 1? Or do neither of them work? What do you guys think? 1 and 2, 2 and 1, or neither? Neither? 1 and 2? Try 1 and 2. If you use 1 and 2, can you see that your outside makes 6? Your inside makes 1. In order to make a minus 7, you would need them both to be negative. And if they're both negative, your last term still becomes positive 2. So it works out. And now we've factored it completely. If this wasn't a quadratic here, in our steps, you would have to repeat steps 1 and 2 for your new polynomial and keep going until you get down to a quadratic and factor it completely. So everything we've done in section 1.1 and section 1.2 has been leading towards this question, to help us factor something completely that's not a quadratic. So we learned about division because it's part of this. We learned the remainder theorem and the factor theorem so we could find something with a remainder of 0. And then we can factor this completely. So let's do some questions. Try these in this order. Start with 5, then do 11, then do 9. Question 9 asks for only one factor, but I would like you to, after you've found the one factor, see if you can factor it completely. And finally end with question 10b.